No, it's not a cool lip spelling to advertise fresh veggies and potato chips. CRISPR is a genome editing technology that can help cure diseases and eliminate health risks. Think of CRISPR as the defense system for a city, the beautiful city of bacterium. The enemy, the phage viruses, send spies, DNA, into bacterium to slowly take control of the city and use it to produce armies, more viruses. Many times, the phages win and take over bacterium. However, if the city successfully defeats the phages, the city would store a segment of the viral DNA in the CRISPR locus. If the phages attack again, bacterium would create an RNA copy of the DNA and scans for a match. It's like the city releases a warrant out for phage spies. When the RNA finds a match, it alerts a protein called Cas9 to cut out the foreign DNA. By doing this, it disables the spy.
Wait, but you haven't even told us what CRISPR stands for. You suck as a teacher. You know why you don't know? You never listen. Shut up and let me explain, okay?
CRISPR is short for Clustered Regularly Interspaced Short Palindromic Repeats. This is because of the way DNA is placed within the CRISPR sequence.
And why does this matter? Well, before the CRISPR technology, genome editing would be slow, expensive, and inaccurate. However, because of the Cas9 protein, genome editing is now quicker, cheaper, and more efficient. Cas9 is very precise, as long as there's a piece of guide RNA. We can now use Cas9 to remove undesirable sections of DNA. However, if we want to change the gene, it would involve a bit more scheming.
Think of your genome as an IKEA instruction manual, and the piece of furniture we're building is you. And because of how complicated those things are, you get 2 copies from your parents just in case of an emergency. If there's a break in the DNA, the instruction manual would either forcefully jam itself together in hopes of fixing it, or it finds the same page from the backup manual and pastes the missing segment into the manual. If we wanted to add green eyes instead of brown eyes, we simply create a similar strand of DNA to sub into the manual. As long as the beginnings and the ends match, the manual won't know the difference.
However, because of the huge potential this technology holds, it also has many ethical issues. Although we can use it to cure genetic disorders and diseases, it opens a door to new possibilities. Soon, we could create designer babies with specific desirable traits.
If we could cure a child of muscular dystrophy, why not add in a fast metabolism, perfect vision, enhanced intelligence, and a buff muscular body? Soon, designer babies may become the new societal standard. Following this just a little won't hurt logic will open a gate that cannot be resealed.
Another issue that has arisen is the tampering of germline cells such as gametes. However, since the offspring they produce will not be alive, they can't consent to the alteration of their genome. Whoa, that was a lot of information. Let's quickly recap.
CRISPR is a revolutionizing technology that can allow us to change our own genome. However, many obstacles still stand in the way, both technological and ethical.
This is the future of the human race, and who knows? Perhaps one day we can all become superheroes.